That was a good save. So introducing Sarah, Pablo, and Marianne. They're all very awesome people that you should really read about. And in the interest of the audience's time, I'm not going to reintroduce them. Marianne has been working on using machine learning for solving real world problems and is really passionate about education. So we're all super excited to hear from all of you, and Chris Albon, who is probably in touch with me via email. I should probably pause. Okay, welcome, Chris. I mean, you've already been here. Oh, my bad. So Chris Albon is here, ladies and gentlemen. Chris is a director of machine learning at Wikimedia Foundation. He's also spent over a decade applying AI and software engineering to social, political, and humanitarian efforts. He's worked with some really interesting challenges, including fairness in elections, getting internet across to people in Kenya, crisis response, and political activism. And he actually got his PhD in political science before creating one of the most popular machine learning websites in the world and moving into this field. So thanks for being with us today, all of you.
Yeah, thanks. Can you hear me?
Yeah.
Just check. Okay, cool.
All right. So the format for today is more of a Q&A. We've already pre-filtered some questions from the students, and we have a live questionnaire ongoing, so you can always post your questions there. I'm going to get us started off with a discussion on your respective journeys into AI. So I can start with one person, you can go around the table. For this, I'll start with Pablo. In a minute each, could you highlight your journey into machine learning and AI and the biggest challenge you dealt with?
Sure, I'll try to keep it in a minute. So I did my undergrad at McGill, and Doina Prekup joined McGill as faculty in my last year. And so she gave her first machine learning course at McGill while I was there, and I took it, and I fell in love with it. So I did my honors project in that, but then I left school, went to work, and I thought that was it for academics. But one day I was sort of itching for something new from the job I had at the time, and I ran into Doina on the street randomly, and I just chatting with her. I told her that I was looking for something new, and she said, "Why don't you come do a master's with me?" And I did, and so I did my master's with her and my PhD. And eventually ended up back in Google Brain. The biggest challenge I think I faced was when I finished my PhD, I wanted to stay in academics, and this was at a time before AI was cool. So there weren't that many jobs out there for faculty, and it was quite challenging. So I basically left academia for 6 years or so. Happy to be back, but that's a challenge that was a thing before. I don't think it's as much of a challenge now, but we may come back to that.
All right, Chris, can we have you next?
Yeah, so I got into ML because I got my PhD in political science, as you said. And for me, at the time, after my PhD, I went to work with 2 Kenyan nonprofits, and then worked with a Kenyan startup, and now I'm at Wikimedia. For me, actually, like the biggest challenge was trying to bridge that gap between machine learning, which has traditionally been from a very, very computer science background, and uses computer science terminology and computer science like paradigms for how they think about things, with my social science background, but also that I was working in essentially social problems, right? And so how do we deal with mass moments? How do we deal with things like privacy and that kind of stuff? And when you're working in nonprofits, working in sensitive areas, it becomes important. Like, for example, don't fly with training data on your laptop because you might get pulled off the plane while, say doing a layover in some country because some law has been enacted or something like that. So how do you think about that kind of stuff while, doing high quality machine learning that scales and everything else?
Sarah, can you go?
Lovely to be here again. It was fun meeting a lot of you yesterday during the intro session. So my journey into ML was very rogue. I was very passionate about economics. I felt like I was destined to work in the World Bank. I grew up, my parents moved a lot across Africa, but I grew up mainly in Mozambique. So at the time, economists were the most technical people I knew. It seemed like they were using data in very interesting ways to talk about the macroeconomy. And a lot of my shift occurred when before embarking on a PhD in economics, I came to the Bay Area to work with economists in the Bay Area. But on the weekends, I was saying we should do something for nonprofits. And I was working with all these machine learning engineers. And it was almost like overnight, I'm like, this is such an exciting toolkit. There's so much that you can do that are beyond linear models. And we can do so much more to map like real world data. I would describe the subsequent years as fairly brute force. I would say the biggest challenge is that being self-taught and embarking on a big, I guess, journey of knowing that you want to do something is, but all the pieces you yourself are finding is that can be quite lonely. And so I think the biggest thing is to retain a sense of self and also to try and seek out community in different ways. But that, I still think that we need to create communities in places that are beyond just a few places, and to help people who are trying to access knowledge in different ways.
That sounds great. Marianne, you want to go?
Yeah, thanks for the invite, by the way. Lovely to be here. So yeah, my name is Marianne. I'm from Brazil. So I did my undergrad here in Brazil. I'm currently here since I'm working from home and so on. So I did like undergrad in computer science, and I was just interested, I think, in general for AI. I didn't know a lot about AI at all. Like I just felt like the concept of making machines that can do smart things was like very interesting. And I think all the questions around intelligence and if we can really make it just sounded quite fun. So I just, while I was an undergrad, I just took a course, which I think is like a very famous course on Coursera by Andrew and Stanford course. So I took that one, which is like basics machine learning. I thought it was quite fun. It was quite different from what I expected. Like at least that course is like a lot of math, but I also found it was quite interesting. So I just continued on that journey, and I was lucky enough to get an internship at Google and be able to do some ML there and like learn more about ML while I was doing the internship. And again, kind of like lucky opportunity, since I have some experience, I got an internship at DeepMind on the current team that I'm working on, and then joining as a full-time now, more than 1 year now. So I work on the applied team at DeepMind. And so a lot of the challenges we face, more specifically on a day-to-day basis, is about like applying machine learning in the real world. And I think like that's a big challenge by itself. Because if you're thinking about machine learning as a research topic, I think it's like quite different than facing it from like, I want to solve this real world issue and apply this technology to like a huge scale and so on. So I think like that's a challenge, but I think also like a personal challenge for me starting on ML. And I think probably a lot of students that are in computer science also relate to that there's just like so much going on all the time and like so many areas. So I feel like that's like a good problem, I guess. Like there's always so much. So I think it's just about like narrowing down that a bit and like keeping you focused on what you're doing. It's a good idea.
So this is a great point you raised. Now to start the next question with you. So a lot of students are asking that, can you tell us about the skills we should get out of university so that we are more prepared to get into data science?
Yeah, I think that's a great question. I feel like there's definitely a lot of paths. And I think like that's maybe why it's so hard. I feel like there's so many ways of doing that. I'll talk about my personal experience, and I think from my background, which is computer science, and I'm also like in an engineering position right now. So I think the most important thing, in my opinion, is just like to get the foundations right, like have a solid foundation and not get lost in so many areas, like so many trendings that are going on. So as I said, like that course I mentioned in Stanford and Coursera, like it's a great course about like just the basics of machine learning. After that, you can pretty much have a conversation about what's machine learning and so on. And then from there, maybe you can go deep into like deep learning and some other concepts. But for me personally, I think getting the foundations is the most important thing. And also make sure that you're practicing things like literally in practice, not just like reading the books, like reading the tutorials, but trying to have your own personal projects. So make sure not just to learn like the frameworks, but try to build your own things with the frameworks. I also think like a great strategy for learning If you're interested in some areas, just maybe trying to implement some papers. So if you're interested in computer vision, maybe trying to implement classic papers on that area, or some other papers that you're interested on when you haven't found an implementation, and maybe share that with the community. As Sarah was saying, I think that's like a great contribution, plus a great thing for you, like just for learning, plus for everyone else. So I think, yeah, that's it.
That makes sense. So yeah, going around the room, I guess it's better to like have everyone unmuted and actually talking rather than go around turn by turn. It just seems more natural. Yeah, feel free to chime in on this. But I would like to add another question, right? So to follow up on like, okay, there are some skills you want to get out, but also what is the best way to approach AI independently? If I have a minimal background in AI and like I'm not in a tech major, I don't have the luxury to just select courses that help me out. So what can I do on my own time as well?
So one thing I wanted to add, in addition to what Marianne said, which I agree with, is if you're interested in deep learning, which is what most people are getting into these days, linear algebra is extremely important. So when I did my undergrad, I passed linear algebra, but I didn't quite have the context for why it was important. And I wish I had, because I would have paid more attention and tried to learn more than I actually did. So I think that's just, in math in general, I mean, is an important thing. Even if you're not going to be proving any theorems, like really having those concepts down, like Marianne was saying, the core is super important. In terms of being an independent researcher, it's, I'm not gonna lie, it's for sure challenging, because you're probably doing it in your free time, and you don't necessarily have the support, both in terms of GPUs or what hardware you need, but also like people to bounce ideas from. It's challenging, and so it really requires a lot of dedication and hard work. I think one of the nice things of the time we live in is with the internet and all these social networks and different websites that we have where you can reach different communities of people that are probably in the same boat as you. So one thing I've learned over the years is that anytime you think you're alone, you're likely not. There's for sure many other people that are in exactly the same boat as you. And so finding those people, there are lots of tools to connect with those people. And there's reading groups, there's free YouTube videos explaining linear algebra or different concepts in deep learning. And really just kind of starting to poke around. Like it's hard to really, I mean, it's good to focus, but it's hard to know what to focus on until you start sort of playing around and digging around into different things. So basically trying to have fun, but putting the time into it. It's going to take time, it's going to take effort. And I think eventually you'll start to realize what the things are that really interest you, and then really start trying to dig into that and reach out to people and network.
I'm going to be a little bit contrarian. So I think that dabbling can sometimes feel overwhelming. So I think that particularly when you start is embarking on, let me look at this lecture here, let me look, just speaking from my own experience, I think it ends up having this effect of diluting your sense of purpose because you feel like the body of knowledge is enormous. I would say that each person has their own best way of learning, but I often recommend start with just a single book. So the book that I always recommend is two. So the Elements of Statistics is fantastic, and then the Deep Learning book, which I guess came out 4 years ago, perhaps. So that's also a great introductory book to many of the topics that you'll need, and it has a lot of at least overview of the mathematics. But by bounding yourself to a book, I often feel it anchors you, and you start to get through some of the early cycles that you need, those foundations. And then related to what Marianne said, which is very important, it's very important to have an applied project. And whether that is you're part of a research collective and you're doing research, or look around your community. The way that I first became passionate about machine learning was working with nonprofits. And I was just like, we need better tools. There's such exciting data. We need more complex tools that can actually map this data in useful ways. And what I tell a lot of the students I work with is I say, don't forget yourself. And a way not to forget yourself is to work with your community. Remember what you bring to the table, which is you probably have your own community and your own problems that you care about. And baking that into how you learn and what you're doing makes you in this very important position, makes you both a student and a teacher, because you have insight into a window of what your community is that other people don't have. So you're immediately anchored as someone who has something to teach. And that's also a very important part of learning. I tell everyone, make sure you teach as you go, because it's the best forcing function to keep you accountable. Because when you teach, as humans, we all get very nervous. And so that means we tend to put the work in because we don't want to look foolish when we're going to go teach someone something else. So it's a great forcing function to keep you accountable and to keep you learning and accumulating knowledge, but also communicating it in a way that's powerful.
Just to reiterate what Sarah was saying, I mean, those are such great points. Like my journey into machine learning was completely through books. Like I love blog posts, I love podcasts, but there's a lot of noise in there, right? And people will talk about it from like other perspective of something that they wrote in an afternoon, as opposed to a book that has gone through this deep review process and is trying to be comprehensive and is trying to walk you through stuff. And I mean, my education in ML has been through books, like slowly working through like Introduction to Statistical Learning, like with a pen, page by page. Like my copy is completely marked up, and then going into ESL, like the Elements of Statistical Learning, and then going into the Deep Learning book, and then the 50 other books around that, and then having some interesting idea of like, oh, what about this kind of model? And like, oh, there's a book that kind of tackles that, and walking through that. And you know, my site, which is visited by lots of people, that was driven out of me, my way of learning. That isn't for other people, although lots of people use it. It's because I take the concepts in the book and I need to use them in my head. And the way that works for me is to turn them into like a little atomic unit of something. So a little atomic, you know, like element of like, oh, here's how we calculate that one thing, or here's how we do that thing. And just having that and slowly walking my way through. And so I think, you know, absolutely right about the books, absolutely right about like some kind of like project that is yours that you're interested in, because if you take some huge big thing that everyone has done before and that kind of stuff, the bar is so high. Like you're not going to win the Kaggle competition like tomorrow, right? But you can do something. My friend is like, he was identifying bees in his beehive, right? Like that's just like his project that he's just working on by himself, and that's sort of his thing. And like, and he's not really competing against anybody else in the bar for like him feeling like he's making great progress is low because there isn't a bunch of other people doing it. And so it's interesting to him. Both those points are really great.
So this is a really good point. So the bar is really high. So this gets us to this audience question, right? If I'm majoring in CS and I'm interested in AI and ML, should I still focus on doing data structures or algorithms and lead code? Like are these tangential concepts in AI, or should I actually focus on them?
I'm going to be controversial again. I would say, so it's unfortunate because a lot of the rubric for how we evaluate people has kind of spiraled. And I would say, unfortunately, we just throw the gamut at poor souls who want to embark on this journey. And we expect them to be both an exceptional engineer, an exceptional researcher, and exceptional at theory, and very good at mathematics. And I would say that most of my colleagues are good in one bucket and are very good at one bucket and good enough in the others, meaning that you don't have to be exceptional. It would be bizarre if you were exceptional in each bucket. In fact, it would be very odd because I'm not sure such a person exists. And what you should do is make sure that you are very good in one compared to your peers. Choose what your strength is. So research, there's room for many different skill sets, and applied, there's room for many different skill sets. You can be a very strong engineer and really help shape the backbone of projects and think about what tooling looks like, but also have a research mind and be able to like banter with your colleagues about what are good ideas. You can be very good theoretically or very strong at really thinking through the mathematical backbone of hypotheses. You can be a good empiricist, which means, you know, you're strong end to end and you have very strong hypothesis statistics. So it's more important to realize what your strengths are and really play to them than to try and optimize for everything at once. But again, there may be different viewpoints here.
No, I'm just going to keep agreeing with you as we go through this, because that is entirely right. I mean, there's no, like, my job, I get hired for jobs to run teams that do data science and ML. Like, my day-to-day is with organizational structure, which is like team management, which is HR, which is strategic direction or system design or those kind of things. But in my interviews, it is not, you know, like when I am applying for a job, it is not unexpected for like a whiteboard to get wheeled out and there's a math problem on there, or there's some kind of coding example, or I'm flipping a binary tree. Like, these things, like, there is an expectation in the interview process that is different than actually a lot of what you do on the day-to-day. And that is the unfortunate fact, but it is the fact. And so, you know, I would not say that things like leak code aren't useful. I would say that they're less useful like in your job, but in the interview process, there will be, you know, likely like a coding pad example, like a coding example that you need to do, and focusing on things that you can do really well, where you can say, hey, like, I wasn't actually that good on the math part, but I crushed the coding part, is super useful, and it's much better than being, you know, sort of like mediocre on both.
Yeah, I generally agree with that. Although I will say that I find that there's a little bit too much emphasis nowadays on wanting to be an AI researcher or a deep learning researcher. And so, you know, you feel like, well, why do I need to learn about databases? Because databases, I'm not going to use databases in my research. And sure, you might not use it on a day-to-day, but I still feel like these foundations, I mean, if it's part of your degree, I wish somebody had told me this when I did my undergrad, because things like databases, I actually didn't pay too much attention to. And there are lots of connections between different fields, whether you're thinking of going into AI, there are many component aspects of it that came from database research and that came from the types of algorithms that they develop for databases. So all of this, even though it doesn't seem all that useful, for me, it seems like it ends up making you a better researcher, engineer, or whatever you're going to be. The other thing is, as you start, sometimes the best ideas come from the most unlikely places. So if you're taking a database course and they ask you for some particular problem, and you realize, hey, this kind of makes me think of this deep learning model that I was just learning about. Maybe I could apply it here. Maybe that's a new paper that nobody had actually thought of that connection, because people don't often aren't always in that intersection of those seemingly disparate fields. But I agree that nobody is the perfect engineer, researcher, project manager, whatever. Everybody has their strengths, and for sure, playing to your strengths is a great thing, because that's what you'll be able to contribute the most to the table. And all that being said, I think also finding the people you work with. So if you find that you are a really good engineer, try to find people that are maybe not as strong as engineers, but are really good researchers or really good at proving theorems. I mean, you'll make a killer combo then, because then you'll be able to sort of leverage the strengths from everybody.
So this leads into a nice combination of questions. So there's an audience question about, I'm interested in learning through making projects for my community, but I'm having trouble thinking about implementing machine learning with projects other than things like image classification or economics problems. Are there other ways to use ML in more approachable, applicable projects? And a second follow-up to that by someone else is more about, has AI and machine learning been used in flight simulation? So we had a question that I really wanted to ask was about, what is the coolest or most exciting non-mainstream project that you have worked on that uses AI and ML? So maybe we could have a round of that.
I feel like the flight simulation question, Chris mentioned an interesting anecdote about being on a flight and losing his data. Perhaps that's where that came up, but no, it's fun. I mean, I think that what is the most interesting data project? So I guess we all have our favorites, but the most interesting for me, relating to Pablo's comment, which I really agree with, I worked with a really strong group of people far better at what they did than I did. And it was for a Delta project. And we were working with Rainforest Connection at the time. And Rainforest Connection, essentially what they do is they are detecting chainsaws in rainforests. And so the whole project was using these recycled cell phones to detect when a chainsaw is present. And this was years before. Now Rainforest Connection works with a Google team, which is really cool. But this was even before I was at Google. It was 2 years before I was at Google. And at the time, they were just starting out. So they were in all these rainforests. And what was exceptional about it was that the people I worked with were way better engineers. The people who were associated with Rainforest Connection were also very good domain knowledge. They had a lot of domain knowledge about the different rainforests. And that's where you really see the pace of your learning accelerate when you're working with people better than you. I always say everyone who's starting out, you should always have a group of people who you feel safe with, and that can be a peer. But you should also definitely work with people who push you. And that's really the secret, is try and work most critically early on in your career with people who are just far better than you, who will push you, who will make you better, because it's the biggest catalyst for improvement.
Coolest project, anyone else?
Yeah. Oh, sorry.
Go ahead, Mary. No, go ahead.
Yeah, thanks. No, I was just gonna like briefly talk about the Open Mind project that I participated on, which I think is like in the intersection with like machine learning and privacy, which I think is pretty cool. And I think like they do a very nice work talking about those things. And this particular project we kind of like just did for a hackathon. So I think it was like maybe 2 years ago, if I remember correctly. And I think also to Sarah's points about like just like you have a team with people that are strong in different settings. This project was mostly around infrastructure. So we were proposing to have like this kind of new technology that could port models, but also in a way that you can give some data so we can run inference, but that you could have some level of security about like the privacy of that data. So you could have a way to make sure that whoever likes running that model, they don't have access to the data that you given them. So let's say like, I don't know, maybe you have like a Google Cloud is running some image classification, but that image is like for some reason very private and you don't want Google to see that image. So you want some kind of guarantee of that. So we're kind of proposing that framework somehow. So I think it's like a very nice and super related to machine learning, but in a technical level is more like infra work, and like you think about how you do those things. So you need some people that are very strong on doing this kind of work, which at that time I wasn't that person, but I had a friend that was. So he was in that team and I could learn a lot with him as well. And I think he could learn a lot about like the ML pieces as well. So I think that's kind of like a fun example that yeah, I really like.
All right.
For me, I think some of my funnest AI-related projects are the ones where I'm combining them with creativity somehow. So I've done a few projects for jazz improvisation or lyric writing or multi-agent RL for a VR game. And I am fascinated by those because the reason I like them is we're using AI in a way that is likely not how most people are thinking of when they're developing the algorithms that we use. And it requires both technical expertise to be able to train and run these models, but also a creative mindset to be able to think kind of how are we going to use these models in a way that they weren't designed for. And I think that those are super fun, and I'm looking forward to doing more of that.
That sounds awesome. So the next question is more about research versus engineering. So a couple of questions in the QA are about what are the challenges or advantages or disadvantages of pursuing ML as a software engineer versus as a mathematician or statistician? And like, what do these things require? Like, is a PhD necessary to do CS research in tech companies and so on and so forth? And there you go.
All right, so maybe I'll start. So as I said, I did my PhD in CS and AI, and I wanted to be a prof, and I I wasn't able to do it. I didn't get a job. And so I joined Google as a software engineer, not doing applied machine learning, but not doing research. And I find there's a big desire for a lot of people to have that research scientist title in front of them. I don't have it, and that's fine. I mean, less now, but I think a few years ago there was not as much recognition of the amount of engineering necessary to get all of these models trained and developed and published and all that. And so if you're just a software engineer, and quote unquote just, you weren't considered like often you weren't considered like as a real researcher, and I really dislike that sentiment. So again, coming back to the point that Sarah was raising about playing to your strengths, if you're a really good engineer, you're going to have a place in that table. And so play to that strength, whatever the title you're given. Like if you're a software engineer, research scientist, really doesn't matter. If you're doing interesting research and you're happy, I think that's good. So really, I think it depends on what your strengths are and how you play and build up those core skills.
Okay. Next question, I guess. So this is an important question. There is a lot of talk about how AI is encoding biases into its programs, by which I assume the software. Any comment on how much flexibility you have to speak up about this from your own identities? I want to continue my work with the trans community, but want to know how I can continue to integrate these things when working in this field. Not to mention, disenfranchised communities don't always have the same amount of data on them as other communities do. All right, who's going first?
So what was the question again? Sorry, I missed the question there.
So there's a lot of talk about how AI is encoding biases into its programs, by which there is separate communities are treated separately, or for instance, image classification doesn't work as well on white people as Black people, and that's a challenge. Also because there's disenfranchised communities don't always have the same amount of data on them. So the question then is, any comment on how much flexibility you have to speak up about this from your own identities?
Sure. I can take this one. So one, I work at a nonprofit. I don't work at a company. We should just say that up front. For us, this is a central issue, and we talk about it all day and night. The idea that we train models on, say, English Wikipedia because it's larger and easier, and then apply that to, say Tagalog like Wikipedia, or Sesotho Wikipedia or something like that, and then like we're transposing those biases over. That is a full. My regular day job is to have those conversations. They're hard. We try to work and do better, and it's part of our plan of moving it forward. I do think I'm in a more privileged position than other people in that we are a transparent organization. You can see all of our models. We don't have any secret models. We don't have all of our code is open source. You can see all of our metrics. You can see everything that we do. You can look at my tasking board for my team chat, my internal team chat, my email list. Everything I do is out in the public. So it's easy for me to say, hey, it's very, I could talk about this all day. In fact, it's my job to be open about this because we're supported by everyone like you all. And so, yeah, we care about this a lot. We talk about it a lot as part of our plan. And a lot of times, it is, where I think that we haven't done so well is in the push to get something out, we take the easier solution. So for example, the classic one is English Wikipedia. Okay, cool, I have 4 developers. They speak various languages, but everyone speaks English, so we can use English Wikipedia, and we don't need to have a translation team to go in to understand what's happening with the data. We can train something on that. Oh, now we need to go to all the languages that are there we want to support. Well, what's the easiest way to do that? We'll just train the model here, then move it over there. And then of course, that produces the huge amount of as you can imagine, taking a model from one community and applying it to the other. I will say one of the things that I appreciated the most when I joined the foundation as the first director of machine learning was that the major models that we use, not all of them, but the major models that we use are very often trained buy data from the community. So Dutch Wikipedia will gather data from Dutch Wikipedia, train a model that we then serve back to Dutch Wikipedia, and then we do that same thing with English Wikipedia, do so with French, et cetera, et cetera, et cetera. Getting coverage across the world for all that is super hard, which leads to the bias problem. But I have really appreciated the amount of effort that has been spent on it and the amount of time that we have spent on talking about that. And it's actually, you know, the Wikimedia organization is open. So it's an open conversation with everyone here. You can come and like literally come and chat with us about it, join our chat room and talk about us. And that's where the team is talking about it. And you can join that conversation or the email list or the discussion topics or like, you know, be part of the planning process for what the foundation does over the next 5 years. All that is open. And so that's great and wonderful. And I have also worked at private companies, which I don't think private companies are, you know, like necessarily bad, but there's a lot less ability for folks to talk about stuff like that because they're, you know, they don't have the authority to say that kind of stuff. Where at Wikipedia, we're totally open, of which I could literally live stream what I do all day and no one would care.
Yeah, maybe I'll speak a little bit here. I mean, it sounds like there's two questions baked in, which is, what is the discourse right now around bias and ethics and our models? And then the second is, it seems specific to the person who asked the question, which is if you're working with a very small marginalized community, what extra difficulties does that bring? I mean, I think that the first interesting aspect of the discussion around bias and ethics is that the conversation and the precision of the conversation, how we talk about these things, is relatively new. And that's largely because we spent a long time just trying to get models that perform well on certain tasks. And then we finally did, and then we're like, oh, wow, so maybe we care about things beyond just test set accuracy. And so the vocabulary that we have, as well as the respect for codifying these additional attributes, is in evolution as we speak. People who work on bias and people who work on thinking about how to measure bias, how to mitigate it, it's a research field, as well as auditing tools and interpretability, which is a large part of what has interested me. Those are research fields that are evolving as we speak, and the body of literature on them is growing, but we are still forming vocabulary and methods and thinking about how to measure this in effective ways, not just for researchers, but for practitioners. And so it's an exciting time for anyone who wants to do this research to join, because when something is in evolution, it's the most exciting time to contribute. The second thing I'll say is that both, you know, I think that research labs, typically a lot of what they're aiming to do is to open source. So for example, all my papers are open sourced. All the code for my papers are open sourced. So if you want to pursue research, even within industry, there's areas where you can contribute freely to shape discourse, both internally and externally. I think the second question is perhaps the more interesting in terms of the difficulty, which is if you're working with a marginalized community that's small, how do you even measure this? How do you even evaluate the impact? And this gets to the core difficulty, which is we typically, to date, have had fairly crude ways to measure algorithmic bias, which is we have pre-labeled data sets for the features we want to analyze. And it's a very interesting and exciting area of research. How can we understand bias without labels? For a community that's small, where we may not have labeled data sets, can we surface where the model disproportionately impacts this subset of this distribution? And that's, again, a super exciting question. I personally am actively thinking about it. A lot of my research work has been looking at it. And I think that it's a broader topic of interest to the community. And I would say get involved. It's exciting. If you're interested in helping your community, now is the perfect time to chime in and to think about some of these problems.
I just wanted to add to what Sarah's saying, and coming back to the question we were mentioning about reaching out to people across the globe with all the tools that we have and building these communities. There's this paper that will appear in EMNLP or already appeared. It has like 50 authors. It's called Participatory Research for Low Resource Machine Translation, a Case Study in African Languages.
Masakani Collective. Yeah, sorry? Excellent. It's the Masakani Collective. It's yeah.
Exactly. And so I spoke to Jade Abbott, who's one of the authors on that, and I was asking her, how did you even come about doing this? Like, how did this come about? And it was really like people starting with their own languages, you know, and they say, we want to work on this. It's challenging. We don't have enough data. And so they start, you know, putting out feelers, and then they find other people that have the similar type of problem. And so why don't we work together? And, you know, you start building these communities and building this network of people that you work with. And now you have something that's a bit of a larger corpus. It's more diverse, and you're all interested in the same type of thing with these low resource languages. And how do we build better models for this type of thing and evaluate these types of biases and these things in a more quantifiable manner.
So there's a student raising hand, so I will allow them to talk.
Hi, hi, can you hear me? Yeah, I thank you guys for being here. I think it's an interesting topic you guys are talking about, and I especially have a question for Dr. Samuel Castro. It's fine. Yeah, I've seen in your bio that you have experience in like flight simulation in one of the company I think you work for. Yeah, and I was wondering, in one of my projects I'm working at school as an electrical system engineer, is developing like a kind of like AR and VR experience for like a UAV system. And I'm wondering how have you used AI and ML in flight simulation, and what application have you used it for? Yeah, thanks.
Sure. Thanks for the question. So just to clarify, that flight simulation job was the job I mentioned that I was itching to get out of when I started my grad school. So I wasn't doing any ML in that. That was pure programming. And as I was, interesting story, I was taking code written in Fortran and assembly in computers that were built in 1980 and porting them to Linux boxes in C++. So very old stuff. Way before GPUs were a thing. But to continue on that point, we just published a paper in Nature last month where we're using reinforcement learning to automatically navigate stratospheric balloons. So this is from the Loon company. Basically, these are giant balloons that are floating in the stratosphere and bringing internet to areas without connectivity. And so navigating these balloons is really challenging because they're basically just surfing the winds. And so you have to, it's a really challenging problem because the winds change. And you have to try to predict these winds, and you have to either go up or down. That's all you can do basically to surf these winds and be able to bring internet to where you want to bring it. So we used reinforcement learning for that. And obviously devils are in the details. It's not one size fits all for these types of problems, but there's a lot of domain-specific techniques that we used for this in terms of what features we used for our models and how we evaluated them and how we sort of iterated on the models. So there's other people doing similar types of stuff for robot navigation that I think would be applicable for what you're saying.
Yeah, thank you. That's a great response. Usually, I've seen people use that mostly like in drones, like they use like some kind of like sensor fusion to get data from different like sensors, and they combine it with like an IMU, where you get like altimeter data and manuometer and things like that. And then they usually use like a Kalman filter to filter out like all the noise and get like different like accurate data. So like right now we are like stuck in how to use like basically apply like those algorithms in order to get like basically what are we trying to do. So I guess I'll learn more into that, but thank you for your response.
Good luck.
Yeah, we have another student, Sabrina, raising hand.
Hi, hello. Are you hearing me? Hello? Yeah. Okay. So I have a question that about, well, you were talking about the different, as Sarah said about something about the different buckets that we need to learn, the different areas of knowledge that you can focus on when you're going into AI. And you talked a lot about being an engineer or a researcher or other positions. So I was wondering if you could just make a quick review of what kinds of jobs that are in the field, like what an engineer does and what a researcher does and what other types of positions do, and what is the knowledge that is expected of each of them, you know, I don't know. Yeah, I guess that's it.
It's interesting because these titles are in quick evolution as well, right? I mean, if we even talk about the field of machine learning, we've had various different iterations and preferred titles, like data science. What was a data scientist like maybe 5 years ago is now a machine learning engineer, and what an analyst was is now a data scientist. And even within a more official rubric framework, like a big company, I would say within the team, there's very little difference to what Pablo was saying. An engineer or a research scientist within Google Brain is treated very much the same. Like you can be an engineer who's very much, you know, leading papers, mentoring other researchers, or you can be an engineer who's really focused on the pipeline. So it's much more flexible in some ways within certain, I guess, specialized industry labs. What I would say is that it's perhaps more important, particularly since I believe, unless someone snuck in, you're all undergrads, I would say it's perhaps more important at this stage of your career to figure out what excites you, because internships typically it's not going to be for a very specific job position. If you're looking for a technical internship, so that would be either on the research ladder or on an engineering ladder, those both considered technical internships, then those are both going to kind of test for across the gamut of these skills of like, do you understand statistics? Do you understand, can you speak about your research projects, but also can you code? And the emphasis put on those different parts will vary a lot company by company. And what's perhaps more important is you figure out what sparks joy when you do it, and then prepare for that, but also, you know, to what Pablo said earlier, enjoy the diversity of your education right now, because it all provides these interesting links later. I will briefly comment on things which are not considered technical roles, but are actually hugely helpful for research projects working successfully. So project management is a huge skill, and project managers within research can be highly technical, but they're working more on how to think about an overall scope of how, for example, hardware is delivered, or thinking about how do we do a moonshot project, things like that. And it requires a degree of technical insight, but you're also much more focused on the big picture. So that's an entire category of like a career pursuit, which might be slightly different in terms of you won't have the same type of technical gamut of interviews, but it'll be much more about how you connect technical concepts to the big picture. But I'm going to pause there because I think this particular question, I'm sure everyone has a slightly different answer for. Or maybe not.
No, I'm right there. Everything you said, I agree with. So if I can just point this way, you're next to me on my screen. So there you go.
We have a lot of polite people on call today.
I can make a quick comment. I think just to add to what Sarah already said, I think that like just once you learn what excites you, I think it makes it easier as well when you're looking for a role, when you're applying. Just like to look at the website as well, like maybe you want to apply for a research scientist position. So make sure like you feel what they're requiring, like maybe they ask for a master's, a PhD, and so on. So like if you see that, oh, I want to be a researcher, like make sure that you're looking for what they actually look on people's like to fill that position. So you make sure that you have the requisites and like you're not using a lot of your time like learning a lot about coding, but actually maybe you don't need a lot of coding for that particular role or something like that. So
yeah, that kind of reminds me. So I'm not sure if this is going to come up, but we should definitely talk about outreach at some point in this panel because so excitement is important for another reason, because it's going to make outreach much easier and more authentic to you. So one thing not to do is to email someone saying, I want an internship, tell me how to get there, because unfortunately, it's just what should come across is your excitement or what interests you, why you've chosen this person to email. The worst thing for a person who receives that email is to feel like this email could have been copy pasted and sent to everyone. And so that's another reason why it's important to figure out what sparks joy in you, because it will also make it easier to figure out who to reach out to. So Chris did a fantastic overview of all his work being transparent and his team, and those attributes of like developing machine learning and data science tools while interacting with the public, while interacting with all these active communities. If you're interested in that, you automatically have this exciting connection, and you can send Chris an email saying, wow, I've also been working on like, how do I open source this particular data tool? The same way, if you were interested in interpretability and read my paper and then sent me a note, I mean, researchers love it when you send them a note about their paper. Let me tell you, the quickest way to a researcher's heart is to be like, oh, I think this could be improved, because it's a great way to start and really exciting conversation about how to improve an idea. So I really recommend, if you're interested in an area, take a paper and come up with a few questions about why did you do it this way? Or I think this could be interesting if it was done differently. And that's a type of outreach that is super successful because it automatically creates a depth of conversation and puts you above like very shallow outreach. So definitely that. Perhaps I think I perhaps jumped ahead maybe in a topic, but I wanted to make sure we got to that because it's one of the most critical advantages that you can have as someone who's reaching out. Pablo, jump in. I want to hear.
Yeah, I just want to add to what you're saying, which I agree with. But if you want to go even the extra step, so asking questions is great. But I think for me, at least, when people have reached out to me, I actually implemented your algorithm and I found this result and I improved on. If you already have tangible results, that's amazing. So I had this paper with this person in Colombia who doesn't have any access to compute. And he's actually going to be starting his master's with me next year. And part of the reason why this worked out, coming from where he did, is because he did a lot of work beforehand, before reaching out to me. And when he came to me, he had these algorithms already implemented. He had some interesting questions with results to sort of back that up. And the additional advantage of this is when you have these artifacts that are out there, whether it's a paper, a preprint on archive or a GitHub repo or something like that, this is stuff you can put on your CV. So when you're applying for jobs, just saying I worked on an interesting machine learning project is fine, but I mean, lots of people do. But if you say I worked on this project and here's like the artifact, here's how many forks I have, here's how many stars my repo has, that's a tangible artifact that really sets you apart from all of the other people that also want to get into this field.
So these points actually lead into tomorrow's panel, where I wanted to ask, like, is it fair that today people have to do so much for a cold email to matter compared to like 10 years ago when people didn't have to do all that much? I mean, obviously it matters that the resources are more accessible today, but it just seems a little unfair if you look at how the field is changing so quickly and it's so hard to get into it today as opposed to like even 2 years ago.
I disagree. I'm gonna politely disagree. So I think a cold email is the best way you have to equalize a field, because the rubric that you face during the interview process is actually, that is what I think is unfair. We now expect people to do all these acrobatics in very different dimensions. But one way within your control that you have is to do a well-crafted email to start engaging with researchers that you admire. And that takes far less time than spending days on LeetCode, figuring out what possible combination of questions that you could be asked, or essentially reading back to back your elements of statistics, being scared that, oh, I hope they don't answer this question. So it's an activity that is more, and it's also an interesting activity in the sense that, so going for your first set of interviews can feel very overwhelming. And it can feel hard sometimes to feel like you're making progress, because often you face a lot of no's in the process, and it can be extremely disheartening. Whereas an email is some way to feel like you're making progress every week because someone you admire reaches back out. And I would say, in terms of where you spend your time, it is one of the equalizers. When someone writes a well-crafted email, I don't look as closely to what school they went to, or to think more, oh, do they have the prestige? I think, wow, they're passionate about the same subject that I'm passionate about. I want to talk to this person. And it leads, I often like schedule coffee with them because actually, I don't know if I'll say that on this chat because I hope I don't get like a ton of emails. But no, it makes a difference. It makes a difference.
Fair enough. I think we can end with Omina's question, which is a really important one. Omina, do you want to unmute yourself and ask the question you posted on chat?
Yeah, I'll just relate here. So my question is, do you ever find yourself anxiety-ridden in your respective field within AI? It's constantly evolving, of course, but I find myself sometimes being discouraged by not knowing enough or thinking that I will never know enough. There's a lot of uncertainty and learning as you go, which is both exhilarating but also seems very daunting. What moment did you feel the most confident in your abilities in this field, which from the outside has such a reputation? And I guess the second question with that would be, what are the implications of kind of feeling or someone who is, you know, thinks they're a jack of all trades, but a master of none? Is that something negative? Or I guess, yeah. Sorry if that was too fast. I'm a little nervous, but I hope you guys got that.
Yeah, I can go. So I can relate to that a lot because my PhD is not in computer science, it's in political science, which is traditionally, my program was a quantitative program, but traditionally political science is a non-quantitative program. You go out and conduct interviews in person and you read books and write case studies. I had a quantitative program, so I had a head start, but I'm coming in from reading books about, coups or an election or history, and then going into computer science or like as in the field that computer science is spawned of machine learning, and then talking to, all the smart folks here and them saying, oh, like I did this all day. I did linear algebra from the start. I didn't do a ton of linear algebra in high school or in college. I went back and opened the book from scratch and was like, okay, here I'm going to go and I'm going to learn it. For me, that learning process has been constant. I study, regularly. Like I regularly, even to this day, am continuing to find stuff, find a new paper that I like, find a new book that came out, move on with that. The anxiety part stopped when I got a job, basically. I think like when I was like, okay, cool, I can earn a paycheck with this base of knowledge that I know. Then I sort of got to the fun part of like, okay, cool, I can afford my rent with the knowledge that I know. Now I want to go to the next thing. And for me, it was really, I focused on areas that I thought I could do really good in and I thought would be my base. And so that was sort of like, in my theory, there was this area that I knew really well, which was not deep learning. That was not how I got into it. It was more on the sort of like shallow learning, social sciencey kind of side. And that was what I was going to start with. And then from there, I got to expand farther and be like, you know what, I'm feeling good. I'm earning a job with this thing. Like I'm building a career, cool. And there's this other cool thing I could do. Oh, let me go read about that. But I could do that from like a position of sort of feeling safe there. And when I got too deep, I'd sort of pull back. But that continues to this day. And to me, it has become the part of it that is not scary. It's the part of it that's fun. Like there is always new stuff coming out. There's new papers. There's, there's this, as Sarah was talking about, this like big boom of great things in AI ethics and trying to apply that and like integrating ideas of sociology into AI. There's so many areas to sort of go, or you could go in another direction and you could look at self-driving cars or generative models and that kind of stuff. You can go in that direction or you can go another direction. And that part of it, I now really enjoy. But I'm probably different from you. I'm doing it from a perspective that I have a job that like is already paying for everything. And I feel like I've established myself in a career and I can sort of go do that. But for me, it was that first job that I got, working in data and coding. And then I could say, okay, I'm good here. Now let's move on and go have some fun.
Yeah, I think those are great points. I agree with all of that. I also wanted to add, I think this relates very well to what Chris was saying once he had his job, that the anxiety was gone and he could sort of start thinking about the fun things that he could approach. I think having that stable anchor, if you can get that, is really, really important, because if your all day is anxiety driven because you don't understand something or things aren't working, it gets to you really, really easily. And so having something where you you're confident in yourself and you know you can deliver, whether or not it's in machine learning, I think is really great. And you can sort of start shifting the balance and then having the machine learning side of things that you're really interested in grow as your confidence in your abilities in that grows, and maybe you can get a job in just doing that. So just as one example, kind of related to what Chris was saying, when I did my PhD, deep networks weren't really a thing. So everything I was doing was mostly theoretical. And when I rejoined research in brain, I was tasked with like training this transformer model. I had never touched a deep network. Like the last neural network I had done was something I coded myself in C++ in like 2000. So it was really challenging. TensorFlow 1, for those that aren't familiar with, had this really weird graph structure that was super hard to sort of wrap your mind around, because Python doesn't run, it wasn't Python just running one go, but it built a graph and then executed. Anyway, super complicated. And to come back to another point that was raised before of having people, surrounding yourself with people that you trust and that are supportive. I had a lot of colleagues that were really supportive and really encouraging. And so I was quite insecure at that time because I saw everybody training these nice deep models. I didn't understand how TensorFlow worked. And so having these people that I could bounce ideas from, and really learn how to train TensorFlow, I slowly started building up my confidence in myself. So what started kind of like as a nighttime project that I would work for fun, sort of became more of a full-time thing as my confidence in that grew. But I had this stable anchor, which was my kind of quote unquote daytime job, which was coding, which I knew how to do really well.
Yeah, I just want to say something pretty quickly, just because I kind of relate to the question as well. And this is like the anxiety of like, oh my God, there are so many things, there's so many interesting areas, and you just like want to go through all of them. And me personally, I don't think it went away when I started a full-time job. But in my case as well, I joined after my bachelor, so I didn't have a master or like in a specific area I necessarily wanted to jump in. So I feel like I agree with Pablo when he says that if you find something that you know that you can do, and you, like there's like your nature area, that certainly gives you like some, like you definitely feel comfortable in that area, and you know that you can do things. So I feel like when I get things done at my job, that definitely makes me like doubt myself less and say, hey, I can do stuff, I know some stuff, and that's fine. And I don't know a lot of other stuff. Now, probably never know, but that's fine as well. I think the important things like know what you're interested in. So like find your area, not necessarily what you're good at, but like maybe what you want to learn more of. So you make sure that you use your time to do that. And also like coming back to the very beginning of the talk, when Sarah said like choose a book, I feel like that can be applied to many other things, like choose one thing and make sure that you're doing progress on that. And that can definitely makes you feel like less anxious, because at least one thing you're getting done, and that's fine. Yeah, just do your thing, I guess.
Yeah, I hear what you're saying. Thank you guys for your responses. I guess it's just hard not to age yourself sometimes with the depth of knowledge that you already have. But I guess that comes with kind of knowing yourself, you know, adjusting your expectations as is required of you, but also sort of just, you know, having a direction to your passions, because, you know, you can be passionate in many things, and you'd be surprised how many things are at the intersect of computer science and artificial intelligence, or really anything. But yeah, thank you guys.
Whoa, I feel like you should have answered the question. That was an excellent hypnosis.
Thank you.
With that, on that optimistic note, we can bring this panel to an end. Thank you so much, everyone. Before I do that, there are 2 office hours going on. So if you leave right now and you want to learn something about whatever we did today is being discussed in these office hours, David and Rohan are having their office hours right now. So you can go and join those. Thank you so much to all of the panelists for making it, despite all of these technical issues and skullduggery. I really hope you guys enjoyed as much as we did. We learned a lot, and see you guys around.
Thank you for inviting. That was really fun. Thanks to all the other panelists.
Thank you. Let's start the recording.
Yeah.
Okay, bye.